So it can be removed. Hello, everybody. Sorry, we need to start in a jiffy. So this is a session on Commons ecosystem. Though the work in the Commons ecosystem is ongoing, but we will try to present some of the early view of the ecosystem and the tools and the templates we are working on. This session will be presented by Francesco Zaccarini, Emanuele Chedini, who has already joined remotely from Bologna, and also I will try to assist them. So I will let Francesco start.
Thank you for cutting your very short idea. It's a real pleasure. I'm Francisco Zaccarini from the University of Bologna. Today I'm in charge of presenting the Commons. Today I'm in charge of presenting on the Commons based concept, which is also for process methodology. My focus is mostly focused on methodological aspects.
Microphone doesn't work.
Yeah.
Yeah, if you can turn it on.
Is it working now?
Yes.
Perfect. My talk will mostly focus on methodological aspects and the principles underlying this concept engineering. In the course of the presentation, I will showcase some of the rich concepts we made and go over the practical steps in the creation and documentation. Before moving to the main topic, I'd like to go over the general framework. Afterwards, I'll open a brief parenthesis on the strategies we developed in Commons to the end of our helping concentrating their effort. Again, this approach has been employed to good effect in the literature. Obviously, that makes the choice of the bridge concept candidates all the more important. It is thus only appropriate that we reintroduce bridge concept starting from that door. Leaving alignments behind for the time being, we can now turn our attention to bridge concepts themselves. The first step in the creation of bridge concept is naturally the selection of the candidates. Given bridge concept's role, the candidates have to be chosen by investigating lower level ontologies and having a rather clear picture of what houses will ultimately look like. I shall also anticipate that one of the bridge concept's core roles is providing a new way for domain experts and standard users alike to engage with ontologies, and specifically reap the potential benefits of tier loads, such following exploiting the ecosystem. The usability is a key factor, and ultimately that means that bridge concept ought to be tailored to stakeholders' needs and desiderata, the ones they need, can interact with, and find more useful. Thus, for the test run on MLOs, we analyzed the existing mid-level ontologies and relied on extensive competencies question to create a first list of candidate terms, to which others were added by means of direct engagement with domain experts, focusing on material modeling for our test run. The relevant terms were aggregated and manually organized in different levels of priority, attempting to individuate and eliminate redundancies and noises in process. In our test, we decided to rely on ontologist expertise for the exploration phase, mostly in order to have more control of the whole process and to set up golden standards. I won't go here in the details of the competency questions and data aggregation, but if you have questions, Dr. Sarkar was a leader in the relevant task. The procedure was then integrated and readapted for general purpose when the next slide, please. The procedure was then integrated and adapted for general purpose when the consortium started working with domain-level ontologies, moving away from competency questions due to matter concerning scalability when a larger number of ontologies could be used as reference. In that case, an area is individuated beforehand, and relevant target ontologies are picked in the domain. Statistical and network analysis employing automatic mapping tools in an ancillary role to sidestep the opacity of linguistic labels define a first ranking of the candidates, which is then refined and integrated by domain experts, taking into account non-abstract features relevant for bridge concept desiderata. Having individuated a list of terms, we have to deal with the fact that next slide, please. Linguistic labels do not wear their meaning on their sleeves, especially out of context. Even before that, polysemy is a widespread phenomenon, and there are good reasons to think that meaning is anything but determinate. The gap between terms and concepts cannot be underestimated, and the issue concerning interoperability, which are at the core of this project, testify for that. At this stage, it is really easy to be led astray by expectation of unity and determinatedness. That often results in frictionless dialectical reflection and the emergence of seemingly unsolvable impasses in dialectical exchanges with other parties. Socratic questions like, what is an industrial process? And related following debates. To avoid that, it might be useful to focus on the problems, that is the datum, and the goals. The datum that different stakeholders employ the same terms in different ways as it befits them. They have different stances on cases allegedly involving certain concepts, and they follow different standard definition. It's Babel Tower. The ultimate goal, on the other hand, is simply to achieve a desirable degree of interoperability. The assumptions that the issue can be solved and the goals met only by finding conceptual grains and unifying the realm under a single banner is not enforced by the landscape and unwarranted. In fact, even assuming that there was a right or overall better concept of, let's say, product or device, it would be meaningless if its use could not be enforced. So it's better to accept a pragmatic form of pluralism from the get-go. Next slide. Everyday communication is a matter of fit rather than match, and coordination is obviously possible despite the widespread phenomenon of vagueness. Issues arise only in borderline cases, where common sense and our no-sharp tools fail. Yet borderline cases are borderline cases, and this become the norm and cause systematic problems. The preconditions are met for the introduction of a new standard or a new paradigm. New tools may be a bit more sharp than the old ones, but still indeterminate enough to allow for a lack of friction given heterogeneity. So we should start imperfect tools a bit more and not defy or deny the way we conceptualize the world. In our case, things are not so simple because we are working with ontologies and such machines. And while human concepts thrive in flexible environments, machines are as rigid as they come, or if we want to keep seeing the symbols and deal with immense quantities of data. These bridge concepts are going to be employed by humans and implemented in ontological environments for machines. There must be different handles for each of the two. This point a far-reaching consequence when it comes to design and creation process of bridge concepts. First, we should not expect to find conceptual unity or univocity of definition underlying aggregated terms. We will instead assume heterogeneity and vague boundaries. Conceptual analysis hence will be focused on finding out similarities, similarities, and common core. Likewise, and more importantly, the task of creating a bridge concept will be one of conceptual analysis. We won't be trying to provide a definition of this or that. Instead, we will be engineering a tool for a specific purpose without further commitments. We aren't defining the concept of the industrial process, but creating ontological entities elucidated in a way which favors usability in a given context enough to be employed in ontology alignment. Pluralism and pragmatism are core assumptions, and that allows us to properly engage with other core standards and the ontology entity belonging to the ontology in the OCES. I reckon that this preamble might sound overly trivial to you. These points are really easy to forget, and sometimes it's better to get back to the basics and make them explicit. I will now leave to you with Professor Gandini, and thank you for listening.
Excellent, Francesco. And then he needs to now run for the airport. I wish that you catch the flight.
Thank you.
Okay, now we are moving to Emanuele. And so we have almost 40-45 minutes. And then Emanuele will present for half an hour and 35 minutes.
Sorry, I lost you. Can you hear me? I can't hear you, Arco. I can't hear, and I don't know if you can hear me. I still can't hear, but I can start the presentation if you hear me. Just let me know from the chat if that's okay. Okay, so I will share my screen and start speaking. Just let me know if you if there are any problems. I will not share my full screen so I can Okay, do like that. Okay. Okay. So the bridge concepts. As, this is how the bridge concepts are actually created. So a bridge concept is generated by using
Just a second, Emanuele. Can you hear me now? Hello, Emanuele. Can you hear me?
Yeah, I can hear you.
Excellent. Okay, continue, please.
Okay. So as Francesco told you, the bridge concepts are a way to find to create a connection between the domain expert users and the top level ontologies. One of the issues that we have found in OntoCommons, coming from the feedback from the user in different workshops, is that top level ontologies are really difficult to use, but there are some advantages in using these top level ontologies. So the bridge concepts are a way to provide an easy connection from the domain to the top level and to facilitate the not only the bridging, the vertical bridging between the bottom and the top, but also the horizontal bridging between different ontologies. A bridge concept is expressed by using this template. This template is, as you can see, is separated in 3 parts, in which we have concept elucidation, and of the concept that will constitute actually the ontological entity, which will be the bridge concept. And then we have a documentation about the domain resources used to develop this elucidation, and the alignment of this concept to existing top-level ontologies or other horizontal ontologies. This structure is designed in order to be to have different target. For example, the domain expert, non-ontology educated people can focus or can fill this part of the template about the depicting, so creating boundaries for the concept that should be ontologized. And then there is a shared section, the concept elucidation section, in which non-ontology educated and ontology educated people can start to define the elucidation that will try to uniquely identify the specific concept. And then we have another part which is only for ontology educated people, that will take the work done in these 2 sections and will create an alignment with existing ontologies. So these sections are unique. The first 2 sections are unique. The last section, there will be one set of table for each of the ontologies that this concept will be aligned. So just let me okay. Okay, so let's have a look at 3 examples that have been introduced, have been already developed in OntoCommons. So the atom, the material device, and the physical matter concept. As you can see, let's start with the atoms. As you can see in the templates, we have we delineate the boundary of the domain of this concept, which is really important because for different domain, there may be a different interpretation of the text. And as you can see, we have different labels. So one important idea here is that we have to disconnect the label to the concept. Label and concept are 2 different things. And while the concept is unique, as the IRI is unique, the label may change. So this is a way to solve the problem to solve questions like, what is a product? What is a process? What is an atom? Well, an atom is a label that can be attached to different concepts. So there may be different concepts that can have the same label, product or atom. So first, domain and labels are to be identified in order to clearly define the bridge concept. There is an example here about the concept of product used in 2 different ISO. They propose different definition of product. So our solution is that these 2 standards will end with two different concepts with different IRIs, but they will have in common an alternative label, a SCOS alt label, that will identify them as a product. Then you can see here the knowledge domain resources related to Atom. You can see here the collection of resources coming from Wikidata, the UPAC Gold Book, which is probably one of the most important reference, the Encyclopedia Britannica, Wikipedia, and so on. So these are an example of resources that you can find in this template. And then we have the elucidation. The elucidation is a common sense friendly definition that try to find compromises between the different definition of atom that you can find in the domain knowledge, and propose something that can be introduced in a definition of an ontology concept. You can see here the elucidation for atom that we developed in OntoCommons, coming from the using the terminologies introduced by the domain knowledge. And we, of course, this is our definition of atom based on the domain knowledge that we consider to be suitable for our purposes. You can have, for example, other definition of, you can have create other concept with a slightly different definition of atom, elucidation of atom, if you want, that can have different elucidation. But this is the one that we consider to be the most useful for our purpose, at least in OntoCommons. So an elucidation always requires some compromises, some choices to be made, but it tries to introduce a rigidity in order resolution to the ambiguities, in order to go forward, to continue and to be able to provide alignment between this elucidation to other ontologies. You can see here a comment also is foreseen in the template that try to explain why we ended up with this elucidation, making reference on the domain knowledge that the template also summarize. So the idea is also to provide the user with a motivation about the choices that we performed in depicting the elucidation. And then we have the alignment. The alignment is the third part, which should be filled by ontology-educated people. And this is it proposes alignment with existing ontologies using different type of semantic links from the more strong alignment, which can be, for example, the equivalency statement in OWL, to the weaker alignment that, for example, are using SCOS relations that cannot be used in reasoning, for example. You can see here the alignment of the atom concept with the BFO. So we identify the ontology entity, material entity, and there is the elucidation of the mapping, the elucidation, and then we have the semantic relation level that we want to use. In this case, the semantic relation level is plus of. You can also choose equivalent or SCOS similarities, and then you here, it's not written here, but we already did this. And then you express the alignment using OWL language. So how to align the IRI of the bridge concept to the IRI of to the BFO. So the explicit alignment action. Okay. This is the alignment with the MMO, which is another type of alignment in which we align this the bridge concept to the concept of atom in the MMO. In this case, with the equivalent class alignment, because we consider that the concept of atom in the MMO is exactly the concept that we built in the bridge concept. This is the alignment okay. Let's shift to another example. Material device, for example. Material device is another example of bridge concept that we developed. It is a class, and as you can see here, the elucidation is trying to. It is a bit more structured in order to express the core of the elucidation, addressing ambiguities and addressing peculiar cases. So the elucidation can also be structured in order to be pragmatically usable in ambiguous scenarios. As you can see here, also for the material device, we have the preference label device, and then we have alternative label that can be introduced in order for this concept to be searched by the users. Here you can see the bridge concept material device and the alignment that we developed to other ontologies. For example, the bridge concept material device is a subclass of these ontology entities in PFO, Dolce, MMO, and so on. It is equivalent for concept for allotrop and Saref ontology, and it is a superclass of MMO device and IEF core machine. So this is how we align material device bridge concept to these ontologies. Physical matter, another example of bridge concept, the core, and then the more detailed definition and the labels that we attach to this bridge concept in order for this to be searchable and reachable by user using a search on the label. So summing up, bridge concepts are an accessible tool. They are standalone concepts. They try to engage domain expert without asking them to be ontology expert, but also give space to ontology expert to align this concept to more than one ontologies. But let's move now, because we have not a lot of time. So let's move now to how we implement in practice this type of approach in an OWL2DL framework. So what we decided to do is to base our framework in OWL-DL. So what we developed is an OWL-DL based framework that we will call Top Reference Ontology OWL that will try to implement this approach in a practical way. You can find this framework in GitHub. If you search for OntoCommons Ontology Framework, be sure to go to the development branch, which is the one that has been more populated. I can show you. It is here. So this is the ontology framework, as you can find in GitHub. You can also open this document in which you have the template with the description of the entries for each single cell. You can also have access to, if you want, to the concepts that has been already developed in for example, here, physical quantity, for example, during the OntoCommons project. Okay, so this is accessible. So we have everything in the GitHub repository. Sorry, I don't know what's happening, what's going on. Okay. The framework is arranged like that. So we have the three top-level ontologies in their OWL version that can be loaded together using this dependency import module. These dependency import module are not mandatory. They are here only if you want to load the full framework together. Otherwise, you can select the ontologies that you need. And then we have the meta part of the reference framework that contains the alignment between the BFO and the Dolce and the MMO ontologies. So if you load this ontology module, you will load the 3 top-level ontologies together with their mapping that has been developed thanks to the work done by the CNR in first order logic and then ported into how. Then the bridge concepts are located here, and they can be used by other ontologies here to be mapped to be aligned with the top level. So these ontologies, so KB, BWMD, some domain ontologies from the MMO can be aligned with, for example, other top level ontologies directly if you want, or you can align this your ontology to a bridge concept that will automatically provide you alignment with the existing top levels directly or through this alignment done directly between the top level ontologies. So as you can see, these bridge concepts are a way to facilitate domain expert or ontology developers at domain level to connect their work to the top level. So trying to address one of the great bottleneck that prevents the use of top-level ontologies on the field, which is the difficulty for the people to understand what top-level ontologies are about. The idea is that we meet in between with a bridge concept in which you, ontology domain expert, provide and depict the concept you need, and the ontology expert will understand that and try to align what you depicted with the top level. So the idea is that you have in mind is flexibility, facility to maintain, update, and integrate, and find a balance between completeness, fluidity, and pluralism. The protege environment is like that. So you can, if you download the top reference ontology, you will be able to open protege, and you will see that you will have in the root of protege, you will have the root of the classes, you will have these 3 branches or ontological silos that will show the ontology tree starting with the BFO, the Dolce, and the MMO. Loading the meta modules, you will also load actions that will allow you to bridge between an ontology to one another. Another important fact is that we also created the annotation that will allow you to copy the template directly in the RDF format. So, for example, you can see the atom bridge concept here in the ontology, and in the annotation you can have all the text, the document, the text that you use to fill the bridge concept template, so that the documentation will be easily accessible by the user, and they will have the motivation and for the alignment, the motivation for this concept to be elucidated like that, and also the link to the external resources and to other resources. So in order to have a really fair environment. Example of usage of this approach. I will go very brief through this in order to leave Arco with some time for presenting the topic. We have some practical example, mappings between top-level ontologies, from a single mid-level top-level ontology to integration with the top reference, and alignment between, for example, the KB through the atom. Let's have a quick look at this. Here you can see the alignment of the top-level ontologies. So these are the classes that has been aligned thanks to the work done by the CNR in first order logic and then ported in AUL-DL. As you can see, we have a specifically dependent continuum, which is a concept belonging to BFO that has been mapped to Dolce. This is another concept site that is shared between Dolce and BFO and space region. As you can see now, it is possible when you refer to an ontology, to an ontological entity that belongs to this subclass, for example, or it is an instance of site. Now you automatically have you are positioning your entity both in the Dolce and both in the BFO ontology. Okay, the first one strategy to align an application ontology or existing application or domain or mid-level ontologies to more than one top level is to use this alignment between top levels. This is a very easy approach, because if you already are committed to BFO, for example, you develop your ontology to BFO, and thanks to this alignment, some, not all, but some of your work will probably be aligned with the Dolce and also with the EMMO, when we will also add the EMMO alignment with the rest. These are an example. For example, the CCO ontology, nuclear reactor concept, and I love this because I am a nuclear engineer. It is a power source. It is an artifact. Then we can go up to the BFO. But if you go to the meta level, which is above the top level ontologies, you can see that it is possible to consider the nuclear reactor in CCO not only a BFO entity but also a Dolce entity belonging to this branch. Example number 2, for example, the BWMD ontology. It is possible using the alignment between top level ontologies to make this concept belonging to both to BFO and both to Dolce, thanks to this alignment. And another example of atom, that in this case we are using. This is a bridge concept. So another strategy is to use a bridge concept like atom, the one that we defined in the OntoCommons project, and then we aligned with the 3 ontologies. As you can see, atom is a concept that it is shared between the 3 ontologies, and if you use the bridge concept, you are automatically aligned with all the 3 top-level ontologies. So then you can select, for example, to enrich your ontology with some specific relation action using relation from BFO, for example. You can do that, and then you can enrich your concept with committing to a specific ontology, but you will always have some fundamental alignment with the other ontologies that may help you in interoperability between other people or other groups that are using another ontology for mapping or for documenting similar data. This is an example of CABI aligned with this ontology using the atom concept. So CABI is here in pink. These are the top CABI concept that can be aligned thanks to chemical entity and atom bridge concept. This can be aligned not only with BFO, there is already an alignment with BFO, but also to other ontologies like Dolce and the EMMO, thanks to the bridge concept mediation. So not only possible to align vertically, but also horizontally, because in this way, given the fact that atom can be shared by, for example, BWMD and CABI, it is possible to create a bridge between BWMD and CABI, thanks to the fact that they both commit to atom as a potential common concept for the alignment. Let's skip to other example. The bridge concept device that I presented before. This is an example of its alignment with the other ontologies. In this way, it is possible for someone who wants to develop an ontology for its application to commit simply to this concept, to bridge concept device, without using any other, without committing to any other top level or mid level ontologies, and then you automatically have a gate that will allow you to use more than one other ontologies to specialize your concept if you need by using action coming from one of these ontologies. So this is also the bridge concept can also be used as a guide. For example, I want to develop an ontology an application ontology that uses device. What are the possible mid-level ontologies that I can use? What are the best suited top-level ontologies for this concept? And looking at the existing bridge concept device will address you to existing ontologies that may be useful for you. So you can select the one that you want to commit more and that you want to use to enrich with more action your application ontology. Let's go fast because I don't want to bother you too much. With this, here you can see now you can see again the structure of the framework. Now maybe it makes a bit more sense to you now that I showed you how to use in practice. You can see here, for example, the KB ontology. That there needs to be an alignment between KB and the bridge concept. So there needs to be a module that declare that the KB atom is a subclass of the bridge concept atom. So this is a work that needs to be done to align the KB entity to the bridge concept. So we need to have this alignment module. We need to have this concept modules that aligns to the top level, and this is how the framework works. You can already download and open some of these modules. We are in we released some concepts, but we are still in an early stage of development and usage. And in the next 1 year and a half, in the Commons project, we plan to add more material and to add more ontologies and more examples to more bridge concept in order to make this approach viable and usable by more communities. And I think that's all from my side. I wanted to give you an overview of Ontocommons, but I think that we already had some idea behind the purpose of this project, which let me summarize in the spirit. Can be summarized by the sentence: we reject a cheap, fast, and simple, non-reusable ontology-based approach to model solution in favor of a pluralistic approach and that promotes interoperability between different conceptualization that are expressed by the different top level or the different mid-level ontologies that we have in our ontology world. That's it for my side. So if Marco can.
Thank you, Emanuele. And there is a form we have prepared, which Emanuele prepared to get your feedback from,
Yes.
on this framework. However, the framework, I think, still needs to be described more. And then if you need any information, please write back to Emanuele or us, or just try to connect to Ontocommons website. And the form link we will share to all the participants, after this presentation, maybe, or maybe end of today.
I already shared in the chat for the animate people. And,
excellent.
So,
but yes, it will have much more reach if we share it in an email, and then I'll try to do that. However, okay, so I can present from here. I do not need to.
Good. I will stop sharing.
Okay, give me.
Any other questions? By Manel or-
Yes, go ahead.
My question is, Manel, I have a question. It is also someone from Ohio University. I see alignment of classes. I wonder if you consider alignment on relations and what is impact of alignment on classes onto relations.
Yes, we also aligned relations between the top level ontologies. So we already aligned relations between top levels. So this has been already addressed at top level. We are also planning to use this alignment between top levels to facilitate the alignment of relations also between mid-level or domain level ontologies, if this will be the case. But this will be addressed in the future. Of course, the relations are a bit more complicated to align with respect to classes and have and can be less treatable. I would say there can be consequences or incompatibilities if you choose relation alignments that is too strict. So we decided to focus first on taxonomies, also because I think that a strong taxonomy is maybe the first thing that someone is trying to reach for, searching for an ontology.
Thank you.
Okay, and is there any more question to Emanuele? Okay, so I will go through very quickly one of the tool we are developing. It's actually an ontology repository. But I will first try to mention this. This is available in the OntoCommons website. This was a recent interview done with Barry. And I mean, you can read the entire interview, but it is just a snippet of that, where he mentions that one of the main services that OntoCommons project can offer is to create a public resource where all the major ontologies, their uses, and their users are listed. I think he's pointing to an ontology repository. And of course, we know that there is no ontology repository available right now. I mean, so we thought that we should take it up. And then it was also in our kind of OntoCommons ecosystem. We thought it can be a good part of it, not being just a repository of ontology, but it can work as a part of the entire ecosystem to facilitate some of the framework, I mean, some of the methodology Emanuele showed you, but to make it much more easier. So I will just quickly go through what we mean by the OntoCommons ecosystem solution. So this is from the basic user's point of view, who are maybe not an ontology expert or may not able to use the framework Emanuele mentioned. But if you want to document your data by semantic, I mean, that is the basic challenge here. We need to find an ontology, or we need to create a new ontology. So we think that, okay, if you want to find existing ontology which will suit your data, you need to have a one-stop shop for these ontologies where you can search and then find according to your term and stuff like that. So also, and there are many ontologies. I mean, you can try to decide yourself like which ontology is suitable for you, but it is much better if you have some kind of recommendation system which will recommend the suitable ontology for your need. And then if there are recommendation, or of course if you search manually, it is very important that you will be able to compare the ontologies, that which one is better according to your need. But then also, if you want to create a new ontology. I mean, of course, then you have to specify competency questions. You have to reuse some part of the, other ontologies. All of this needs to be done under a common ecosystem. This is our goal, that how to bring these different methodologies under the common ecosystem. Then after you build the ontology, and then of course Suil will be very much interested that you need to be able to edit the ontology collaboratively. So there needs to be some kind of CI/CD process. You need to map the ontologies with other ontologies. You need to annotate the ontology properly, so the documentation needs to be right. And then in the end, you need to publish the ontology, maintain the version, and then support the evolution of its, all the changes. So how we can do that? So we are selecting some of the tools, and it is not exhaustive. We got to learn many different other tools, which we will try to integrate also. But then industry portal will work as a repository. Ocean is another tool developed by NUI, which will be used for the ontology editing and annotation. LOT is a methodology proposed by UPM, which kind of talk about how you can collect competency question, develop ontology, maintain ontology, etc. Then we have a fairness evaluation tool called OFAIR. And then in the end, the number 5 TRO is actually representing the underlying framework which Emanuele talked about in last half an hour. So now I'm not going through this. This Emanuele just presented. You can understand. I'm just trying to make a reference. This is what we call the ontology stack from the TLO to the domain level ontology and also the application level ontology, completely mapped through this framework. But then now I want to focus more on this ontology repository. The purpose, of course, as I say, to bring together the industrial ontologies. The scope is to cover all the sectors, different industrial sector, but at the same time, we need to also store the mapping between the ontologies, because this is one of the most prominent goal of OntoCommons. So we chose an existing technology called OntoPortal technology. It was earlier called NCPO, and we hosted this technology. It is the backbone of our portal, and we hosted it in our server here in this institute, and we call it Industry Portal. It is already live. You can go there and see this portal. We have around 32 ontologies right now. We actually hosted IOF core, the release. The recent release. But then, what are the components of it? For sure, you can see one of these. For every ontology, you can see a lot of metadata. The metadata are actually here configured through something available for the fairness guided metadata. They call it. It is called MOD 1.4. So we followed that, and then we have a lot of metadata. Not everything is shown here, but then you can provide many information for a certain ontology. You can maintain the version, so all the version will be available. At the same time, you can see how much fair is your ontology in terms of this metadata, so that is there license, is there other problems, you can see and also get an explanation and fix your ontology, according to that. Not exactly ontology, but the metadata of the ontology. But then now coming to the interesting part, that okay, now you have a requirement, you have a competency question. Say, for example, say you want to find the function or capability of an equipment. And you write that competency question, and it will recommend you some of these ontologies listed with some fitness score. And then, okay, so one of the first ontology it recommended is MSDL. So okay, let's go there. And then you can see that how these ontologies are mapped to each other. So say, okay, there is not, one ontology is mentioning this concept. many other ontologies are also mentioning this concept. So you can see that how this single concept is mapped to different ontologies. And then it is not fully complete. We are trying to work on that. So we will provide many other functionalities. For example, right now it is only one set of mapping you can store, but we want to open it for different contexts. So for example, some institutions, some organization want to store their own mapping, which they think is more appropriate, so they can store it according to for their own context. So we call it context-dependent mapping, and there will be some type of facility to do that. Also, you can upload many mappings together as a bulk upload and stuff like that. And then, similarly, you can create mapping with like more rigorously with axiom and then stuff. And then also you can visualize mapping. So you can see here the capability is available in 5 different ontologies, and then you can see the relationship between them. Now coming to the evaluation part, of course, as I said, that you need to evaluate multiple different ontologies. So we already integrated the fairness code, but then fairness code is just one aspect of the evaluation. You need to check that whether, say, ontology has a developmental pitfall. So there is a checker from UPM, it's called OOPS, as many of you know. So we want to integrate that. Also, there are many metrics which are available, and then we want to integrate those third-party metrics calculators along with this. Inside the industry portal. So for each ontology, you can find some metrics, for example, completeness, fitness, and all other metrics, you know. Now, you now want to use the ontology for sure. So you can download the ontology, but then we want to make sure that when you download a domain ontology, you are able to download all the mappings towards the top level ontology. And then it may be that you are not interested in all top level ontology. You love BFO, okay, you can just select BFO. It will be only linked to the BFO. If you want BFO Dolce, you can select BFO and Dolce, and all the mappings to the BFO and Dolce will be downloaded. You can directly open it in the Protege and then start populating your class and then use it for data documentation, whatever you will like to do. But then also we are trying to put some features so that you are able to edit this ontology online. So this is the Ocean tool developed by Nuit, and you can, you are able to do most of the stuff in the Protege in this online tool. Now, just finishing, so where we are in terms of OntoCommons ecosystem framework, this is a kind of percentage of the status where we are right now. So what we mean by this complete picture of OntoCommons ecosystem is that this framework will help you to do intra and cross-domain data documentation. So how there can be, so it will make sure there are interoperability between ontologies. So of course, whatever ontology we take into account under this ecosystem, the alignment, most importantly, as Emmanuel said, is done pluralistically. That means not with just one top-level ontology. We are doing it with many different top-level ontology, BFO, Dolce, and then EMMO. There are technical principles, which is very important, that also we are collaborating with IOF, how to develop this technical principle and as a single most documentation. And then, of course, this evaluation, as I said, and then search, annotation, and recommendation. And then, of course, the other recommendation tool, as I mentioned. So this is what we call the OntoCommons ecosystem. And we will, as I said, we will try to work on it more in the coming year and then complete it. But then we want your input on that. So please write to us and then join the GitHub, and then we can surely have some great input from you. Any question to Emmanuel and us? Yes,
one question is, what about things like Ontology or Ontoportal, Bioportal?
Yes.
What are the difference and what are the links or not, and politically and strategically? And
yes.
so on?
So it's a very good question. Actually, you can see some of those some of the similarity is between. I think I'm.
I think
Yeah.
that for people that is out, they cannot hear you if you don't use the mic.
Oh, okay.
That's
Yeah.
my experience.
I will repeat the question.
Yeah,
I
if
think
you
that
can.
you should repeat your question.
The question is it working?
In the base, I believe.
No. It's okay. The question was, what about things, I would say things,
Yeah.
like general class, like Ontology,
Yeah.
and which is mainly on bio
Yes, I know.
Cortex,
Yeah.
and Bioportal also.
Yes.
And are there models? Are
Yeah.
there competitive? Are there, what is the position and the concepts?
Yes, actually, very good question. I mean, if you can remember the Ontocommons ecosystem solution we are trying to propose, it is very similar to what he proposed. If you know about this professor called he was working with Ontoportal, Bioportal, and then OBO Foundry. So he has OntoBee, OntoFox, and then all sort of zoo animal type of tools to do exactly what we are proposing to find ontology, to map them, to have like different things. The difference is that we are following Ontocommons framework, the ecosystem Emanuele just explained, with our typical like mapping strategy. So it is exactly the same thing, but of course we are following this particular mapping technology. So it is not only PFO, it is all the top level ontologies, and then so something.
Do you plan to publish some ontologies that are already there, or?
As I said, that it is for industry. Of course, there are some ontology in the bioportal, I know, because bioportal is not curated so much. So like it's everybody published ontology there. Some ontologies, of course, very specific to industry, because there are chemicals and then there are certain biochemicals and stuff like that. Of course, we want to bring them in the industry, but this is specifically for the industry, so not biology. So that is the difference between bioportal and industry portal in a sense. Yes, Yves.
Yes, thank you for this very interesting presentation about the methodology. But I was also wondering about two things. The first one was in one slide of Emanuele. I think there was not in the bridge concept, but in one ontology, the multi-heritage of the right, for instance.
Yes.
And I question myself about the consequences of this possibility. If people can show depending and the consequences also at the technical level. But another thought, because this is a very interesting session, you mentioned ARCO, that we have made this image mapping and so on. Upload and download all the links.
Yes.
And you can also mention the question of the relationships.
Yes.
And when we want to make clear the fact in the industry, for instance, we express this fact in a sentence. For instance,
yes.
Firm as a flow rate of 10 cubic meter. So if I understand well, we can make it as a template. We will use it for different kinds of expression of physical quantities for different kinds of equipment. If I understand well, this simple sentence is one line in my paper. If you link all these this stuff. The problem is material entity, and they call me one who is an ontology from the Ecology Institute and also from the PCA and so on. So we have maybe hundreds and hundreds of lines.
Yes.
And if you see, consider that you have maybe millions of files to describe a plant, for instance, I question myself about the dimensioning of this.
Yeah, this is very. So for the first question, I mean, I will let Emanuele answer if he has heard the question.
No, I'm sorry, I didn't understand anything.
Yes. So okay. So the first question was the inheritance problem, as we are doing with the multiple top-level ontologies. And the second question was that if we are trying to do this framework for a lot of ontologies, what's about the scale of the dimension of it? But then, I mean, actually, I have to draw an end to the session as like Hedy is pointing to me. We are going for the lunch, and I'm sorry that Emanuele is not with us here. Otherwise, I would have asked Yves to just talk to him. But then I will try to make a contact, and then as we talk, sometimes we will try to make that question, answer in the future.
Okay.
Sorry,
Have a good
Emanuele.
lunch. I'm going to have a lasagna in Bologna. So.
Oh, excellent. Thank you so much for joining. Okay.
Bye. Thanks.
Okay, that actually concludes this workshop. So now you are free to have lunch and then have a trip to the mountain, whoever is staying with us. And thank you so much for being with us for these last 4 days.
You will climb a different fire.
Yeah.
Pretty quick for the lunch.
So yeah, I could not take your quiz.
I think.
Yeah.